This is the State Route 71 Blackbird. It is the fastest jet-powered aircraft ever built, and to this day, no plane has surpassed it. It flew at the edge of space, photographed entire nations in a single pass, and outran every missile ever fired at it. Not one State Route 71 was ever lost to enemy action. We have modeled the Blackbird in intricate detail to show you exactly how this machine worked, and why it remains the most extraordinary aircraft in history. My name is David Webb, and this is Blue Paw Print. Overview. The State Route 71 was born from fear. In 1960, a Soviet surface-to-air missile shot down an American U-2 spy plane over the USSR. The pilot, France's Gary Powers, was captured. It was a catastrophic humiliation for the United States. Military commanders knew immediately that the U-2 was finished as a reconnaissance tool. They needed something that no missile system on Earth could touch. The answer was the State Route 71 Blackbird, developed in absolute secrecy by Lockheed's elite Skunk Works division, led by the legendary engineer Clarence Kelly Johnson. The Blackbird was not an evolution of existing technology. It was a complete reinvention of what an aircraft could be. The State Route 71 was 107 feet and 5 inches long, 74 meters. Its wingspan was 55 feet and 7 inches, 94 meters. It stood 18 feet and 6 inches tall, 64 meters. Its maximum takeoff weight was 172,000 pounds, 78,000 kilograms. Only 32 aircraft were ever built. Each one was assembled almost entirely by hand. The State Route 71 entered service with the United States Air Force in January 1966 and flew operationally until 1990. With a brief reactivation until 1998. In its entire operational life, not a single Blackbird was ever shot down or damaged by an enemy. The crew. The State Route 71 carried 2 crew members seated in tandem cockpits, a pilot in the front and a reconnaissance systems officer, known as the RSO, in the rear. The pilot controlled the aircraft while the RSO operated the sensors, cameras, and defensive systems. The two communicated constantly because at Mach 3, 85,000 feet, there was no margin for error and no time for hesitation. Both crew members wore the S-1031 full-pressure suit, a garment nearly identical to an astronaut's spacesuit. At 85,000 feet, the atmosphere is so thin that an unprotected human being would lose consciousness within seconds. The pressure suit kept each crew member alive in an environment where the outside air temperature was negative 70 degrees Celsius. The suits were so bulky that cockpit controls were deliberately designed oversized to allow operation with gloved hands. Both crew members sat in specially designed Lockheed 00 ejection seats, capable of safely ejecting the crew even from a stationary position at ground level. To eject, each crew member pulled a D-ring located low on the seat between their legs. The canopy would blow clear, the seat would fire, and the parachute would deploy automatically once the crew member descended to 15,000 feet. The cockpit. The pilot's cockpit was a confined space, functional, purposeful, and stripped of anything unnecessary. The front instrument panel displayed rate of climb, artificial horizon, altitude indicators, and airspeed. The throttle section sat to the pilot's left. The flight stick was positioned between the pilot's knees. Controls on the stick allowed communication with the RSO, with ground crews, and with the tanker aircraft required for every mission. Flight controls were not duplicated in the rear cockpit. Only the pilot could fly the State Route 71. If the pilot was incapacitated, the RSO had no way to take control of the aircraft. The RSO's position in the rear cockpit was dominated by the systems used to operate the Blackbird's intelligence-gathering equipment. Both crew members had independently controlled map projectors mounted in front of them, projected displays showing their real-time position relative to the mission route. One of the most unusual features of the cockpit was the temperature. While the external surface of the State Route 71 at Mach 3 reached temperatures above 300 degrees Celsius, the interior of the cockpit could become bitterly cold, sometimes dropping well below -30 degrees Fahrenheit. The cabin cooling system used the aircraft's fuel as a heat exchanger, dumping thermal energy from the cockpit into the JP-7 fuel before it was burned. The fuel itself reached 316 degrees Celsius by the time it entered the combustion chambers. An environmental control panel to the left of the airspeed indicator allowed the crew to manage cockpit temperature manually. The windscreen was constructed from 25-inch thick solid quartz glass, fused ultrasonically to the titanium frame. At cruising speed, the outer surface of the windscreen reached 600 degrees Fahrenheit. The quartz was chosen specifically because it would not distort, blur, or fracture under those extreme thermal conditions. The airframe. The SR-71 shape was not chosen for aesthetics. Every surface, every angle, every curve served a specific aerodynamic or thermal purpose. The aircraft's distinctive chined fuselage, the sharp, flattened edges running the full length of the body, reduced radar cross-section by deflecting radar energy away from the source. The State Route 71 was one of the earliest aircraft in history to incorporate stealth principles into its fundamental design. The airframe was constructed almost entirely of titanium alloy, comprising 93% of the aircraft's structural weight. Titanium was chosen because aluminum, the standard material for aircraft construction, would simply melt. Mach 3.2 aerodynamic friction heats the external surface of the airframe to temperatures exceeding 300 degrees Celsius. Aluminum loses its structural integrity well below that point. Titanium could withstand it. There was a significant problem. In the early 1960s, the United States had very limited supplies of titanium. The Soviet Union was the world's largest producer. The CIA, using a network of dummy corporations, secretly purchased Soviet titanium from America's principal Cold War enemy to build the aircraft specifically designed to spy on the Soviet Union. The SR-71 skin panels were not welded together. They were connected with a system of interlocking corrugated panels designed to expand as the aircraft heated up. On the ground, at room temperature, the panels did not fit together perfectly. The aircraft actually leaked fuel on the runway before takeoff. This was not a malfunction. It was by design. The panels would seal completely once the aircraft reached cruising speed and the entire structure expanded under heat. Every state, Route 71 took off with fuel dripping from its skin. The aircraft was painted black, not for camouflage, but for thermal radiation. The black coating absorbed radar energy, reducing the aircraft's radar signature. More importantly, it radiated heat away from the airframe, preventing the internal structure from accumulating dangerous levels of thermal energy during sustained high-speed flight. The engines. The State Route 71 was powered by two Pratt & Whitney J58 afterburning turbojet engines, one of the most extraordinary power plants ever built. Each engine produced 34,000 pounds of thrust with full afterburner. Together, the two engines generated more thrust than any other air-breathing aircraft engine combination of their era. But the J58 was not a conventional engine. At low speeds, it operated as a standard afterburning turbojet. As the aircraft accelerated past Mach 2, the engine's operating mode changed entirely. Bypass valves opened, bleeding air from the fourth stage of the 9-stage compressor and routing it through 6 external tubes directly into the afterburner, completely bypassing the core of the engine. At that point, the J58 was functioning as a turboramjet, using the ram pressure of the supersonic airflow itself as the primary source of compression. At Mach 3.2 in full afterburner, the engine itself contributed only 6% of total thrust. The engine inlets contributed 54%. The ejector nozzles contributed the remaining 4%. The engine was effectively the least important part of its own propulsion system at cruise speed. Each nacelle was fitted with a movable conical spike at the front of the intake, called the inlet spike. This spike translated rearward as flight speed increased, managing the position of supersonic shock waves inside the inlet to prevent unstable airflow from reaching the compressor. if the shock waves moved out of position and entered the engine in an uncontrolled manner, a condition called an inlet unstart. The asymmetric thrust produced by one engine shutting down while the other continued at full power could be violent enough to injure crew members and, in early aircraft, cause a fatal loss of control. Later, automated inlet control systems managed this problem. Starting the J-58 required a specialized piece of ground equipment, the AG-330 starter cart, powered by two Buick V8 racing engines connected to a common output shaft. The standard aircraft starter systems used by the Air Force were not powerful enough to turn the massive J-58 compressor. Conventional jet fuel could not be used in the state Route 71 at all. At Mach 3, the temperatures inside the fuel system would cause standard aviation kerosene to ignite spontaneously and destroy the aircraft. A completely new fuel was developed specifically for the Blackbird, JP-7. JP-7 had an extremely low vapor pressure and an exceptionally high flash point. It was so stable that you could hold an open flame to it at room temperature and it would not ignite. Because JP-7 was so resistant to ignition, a conventional spark ignition system could not light it inside the combustion chamber. A chemical called triethylborane, known as TB, was injected into the engine each time it was started and each time the afterburner was lit. TB ignites spontaneously on contact with air. Each engine carried enough TB for 16 afterburner ignitions per mission. Fuel consumption at cruising speed was approximately 8,000 gallons per hour. The State Route 71 carried fuel in 6 tank groups, 9 stores in total, holding 12,219 U.S. gallons. The fuel served a second critical function beyond propulsion. It was the aircraft's primary heat sink. Before entering the combustion chambers, the JP-7 absorbed thermal energy from the cockpit, the hydraulic systems, and the airframe structure. By the time the fuel was burned, it had already reached 316 degrees Celsius. Refueling. Every State Route 71 mission began with a fundamental problem. The aircraft was too heavy to take off with a full fuel load. The skin panels were unsealed at ground temperature, and the wing structures had not yet expanded to their flight geometry. The State Route 71 took off with a partial fuel load, climbed to altitude, and immediately rendezvoused with a specialized KC-135Q tanker aircraft. The KC-135Q carried 2 separate fuel systems, JP-4 for its own engines and JP-7 for the Blackbird. It was equipped with a modified high-speed refueling boom capable of operating at near the tanker's maximum airspeed. After taking on a full load of JP-7, the State Route 71 accelerated to cruise speed, the airframe expanded and sealed, and the mission began. Without the KC-135Q, the State Route 71 could not operate. Every mission depended on a chain of tankers positioned precisely along the flight route. Navigation. Flying at Mach 3. 2. The State Route 71 covered approximately 1 mile every 7 seconds. At that speed, a navigation error of only 1 degree would place the aircraft miles off course within minutes. Standard inertial navigation systems of the era were not sufficiently accurate for the SR-71's mission requirements. The solution was the astro-inertial navigation system, known as the ANS and nicknamed R2-D2 by crews. The ANS was mounted in a housing on top of the aircraft's fuselage. It tracked stars through a quartz optical window, even during daylight, even at Mach 3. 2. And used the positions of those stars to continuously update the aircraft's internal navigation system. The ANS could fix the aircraft's position to within 300 feet. It operated day and night, in all weather conditions, with no signal that could be detected or jammed by enemy forces. Both crew members had independently controlled map projectors displaying the aircraft's real-time position. The RSO could also use a video view sight, an electro-optical system providing a 5-inch display of terrain passing below the aircraft to visually cross-check the navigation fix. Reconnaissance systems. The State Route 71 carried no weapons. Its only defense was speed. Its purpose was to gather intelligence across vast areas of denied territory and return that intelligence safely to American analysts. The aircraft's sensor payload was carried in the fuselage chins and in removable nose sections that could be configured for different mission requirements. The primary imaging systems were two high-tech operational objective cameras providing stereo imagery across the full width of the flight track. An optical bar camera provided continuous horizon-to-horizon coverage. The Hicon technical objective camera could be directed up to 45 degrees left or right of the aircraft's centerline for detailed coverage of specific targets. The film systems used in these cameras were developed specifically for the State Route 71 and represented the highest resolution aerial photography technology of their era. In addition to optical cameras, the State Route 71 carried electronic intelligence equipment, systems designed to record the frequency, strength, and wavelength of radar emissions, radio transmissions, and other electronic signals from the territory it overflew. The RSO operated all of these systems from the rear cockpit. A sophisticated electronic countermeasure system was also installed, capable of jamming acquisition and targeting radar used by enemy air defense systems. Though the SR-71's primary defense was always its speed and altitude, the ECM system provided an additional layer of protection during the most dangerous phases of a mission: performance and evasion. The State Route 71 operated at altitudes above 85,000 feet, more than 16 miles above the Earth's surface. At that altitude, it was above the effective ceiling of every fighter aircraft and the vast majority of surface-to-air missiles operated by Soviet and other adversary forces during its service life. When a missile was detected in pursuit, the standard procedure was simple. The pilot engaged full afterburner and accelerated. The State Route 71 was faster than anything that could be fired at it. In July 1976, State Route 71 set the absolute world altitude record of 85,069 feet. On the same day, a second State Route 71 set the absolute world speed record of 2,193. 2 miles per hour, Mach 3.32. Both records still stand today. No operational jet aircraft has ever flown higher or faster. During its service life, State Route 71 crews flew missions over North Vietnam, the Middle East, Eastern Europe, and other denied territories. In 1973, Blackbirds provided critical imagery of the Yom Kippur War. In 1987, crews based at Kadena Air Base in Japan flew missions over the Persian Gulf, identifying Iranian Silkworm missile batteries threatening commercial shipping. In every engagement, every overpass, every mission flown over hostile territory, not one State Route 71 was ever lost to enemy fire. Over 4,000 missiles were fired at SR-71s during the Cold War. Every one of them missed. Retirement. The State Route 71 was retired by the Air Force in January 1990. The official reason was cost. Each flight hour cost approximately $85,000. Operating the small fleet consumed enormous resources in specialized training, dedicated tanker aircraft, and purpose-built ground equipment. Advances in reconnaissance satellites had reduced the perceived need for manned overflights. Military commanders who had relied on the Blackbird protested loudly. Congress overruled them. 2 aircraft were reactivated in 1995. Final termination came in 1998. NASA flew SR-71s for high-speed research until October 1999, when the last Blackbird landed at Edwards Air Force Base and the program ended permanently. 12 SR-71s survive in museums across the United States. The aircraft that set the world speed record in 1976 is on display at the Smithsonian National Air and Space Museum in Washington. It flew from Los Angeles to Washington in 64 minutes and 20 seconds on its final flight in 1990, still the fastest transcontinental flight in history. Conclusion. The State Route 71 Blackbird was the product of a specific moment in history, a time when the United States needed to see its enemies clearly when satellites were not yet capable of doing so, and when the only solution was to build something that moved too fast to be stopped. Kelly Johnson said that everything on the State Route 71 had to be invented. He was not exaggerating. The fuel had to be invented. The engines had to be reinvented. The navigation system had to be invented. The pressure suits had to be invented. The titanium fabrication techniques had to be invented. Nothing about the State Route 71 existed before the State Route 71 demanded it. No missile ever touched it. No fighter ever caught it. To this day, more than 25 years after its retirement, no aircraft has replaced it. The world's fastest jet still belongs to the Cold War. If you want to learn about another machine that changed the course of history, watch our video on the B-29 Superfortress, the bomber that ended World War II. Thank you for watching.